Morning dear students, welcome to Unacademy, welcome to Kreatryx channel and welcome to Impulse batch. Before going to start today's session, let me introduce myself. I'm Kataru Veera Swamy. I did my MTech in Systems and Signal Processing and my favorite subjects include Signals and Communication, and currently I'm associated with Unacademy, and if you want to purchase any course on Unacademy, you can use my referral code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions, namely the Plus subscription and the Iconic subscription. In the Plus subscription, we have live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. And we have rank improvement batches as well. Coming to Iconic subscription, a personal coach is allotted to the student who will prepare the study planner, study booster sessions are there, separate test analysis is taken for each and every student, dedicated doubt clearing instructors are there, and preparatory study material also given to the students. Coming to the fee structure, if a student is planning his GATE or ESE preparation in Plus subscription for 12 months, that is 1 year program, this costs around 27,225 rupees only after applying the code KVS Live. GATE or ESE preparation Plus subscription for 18 months, that is 1.5 year program, this costs around 34,650 rupees after applying the code KVS Live. And in Plus subscription for 24 months, that is 2 year program, which is ideal for second year students, this costs around 39,600 rupees only after applying the code KVS Live. If you come to Iconic subscription, for 12 month subscription, it costs around 45,225 rupees only after applying the code KVS Live. Iconic subscription 24 month subscription costs around 66,600 rupees only after applying the code KVS Live. And these are the current, this batch is going to start from tomorrow for EC students, Laksha batch for 2022 aspirants, and we have Arohan batch for 2023, and the starting subject is Network Theory by Siddharth Sabharwal Sir. And for electrical students, Laksha batch for 2022 and Arohan batch for 2023, and the starting subject is Network Theory by Siddharth Sabharwal Sir, and this starts on 30th of June, tomorrow at 7 AM. If you want to take the subscription in this batch or the previous batch, you can use my code KVS Live, with which you will be getting 10% discount. And from July 1st, there is a chance of, the subscription prices are going to increase, and I suggest you to take the subscription as soon as possible so that you can beat the price hike. And Unacademy is coming with a new feature in its app, which is nothing but efficient revision via digital notes. Okay, this is one more feature that is going to come in Unacademy app. And there is one more information that suppose if you are watching any videos and if you have any content, inappropriate content or abusing content, you can report and you can win prizes also. Now let's start. Those who are watching, please confirm whether my voice is clear or not. Please confirm. Please confirm whether my voice is clear or not. Please confirm whether my voice is clear or not. Am I audible? Yes, thank you. Observe here. See, in the last class, if you remember, we were discussing the causality and stability of a discrete time LTI system in terms of Z transform. Causality and stability. Do you remember what are the conditions I gave you? What are the conditions? So we'll spend an half an hour with Z transform. After that, we'll go to the continuous time Fourier series. Right. Now, what are the conditions? The first condition is like this. For a discrete time LTI system to be causal, for a discrete time LTI system to be causal, what do you know from LTI systems? Its impulse response must be 0 for n less than 0. And for such kind of impulse response in terms of the transform, ROC will be outside of the outermost pole, outside of the outermost pole, including infinity, including infinity. Second point, suppose if you are given a rational transfer function, for a rational transfer function to be causal, some conditions I gave you. What are those? First one is ROC must be outside of the outermost pole, the second condition which has to be satisfied is when expressed in powers of z, when expressed in, these statements are very important, powers of z, power of numerator must be less than or equal to power of the denominator. Power of the numerator must be less than or equal to power of denominator. And the third point is for a discrete time LTI system, for a discrete time LTI system to be stable, what is the condition? ROC of its transfer function, ROC of its transfer function or system function must include unit circle, unit circle. If your ROC of your transfer function includes unit circle, then definitely that becomes stable system. Okay, now we'll do one thing, we'll try to examine this causality and stability by taking an example. So the question is like this: discuss the causality and stability for the transfer function h of z is equal to some 3 minus 4z inverse by 1 minus 3.5 z inverse plus 1.5 z power minus 2. This is a transfer function. Now you have to discuss the causality and stability. If you remember, similar kind of problem we have done in Laplace also while discussing the causality and stability. So here no ROC, nothing is given, means you have to consider for all the possible cases. You have to consider for all the possible cases. Now do one thing. First of all, try to draw the pole zero plot. For drawing the pole zero plot, factorize the denominator. What are the factors? I can write h of z as 3 minus 4z inverse upon, if you try to factorize the denominator, you will get like this. 3 and 0.5 are the factors. 3 and 0.5. If you resolve or if you factorize the denominator, you will get something like this. Now after this, resolve this one into partial fractions. Resolve this one into partial fractions. How to resolve this one to partial fractions? Substitute z inverse is equal to, see, I first of all try to make this term as 0. How to make this term as 0? Substitute z inverse is equal to 1 by 3. So if you make this term as 0, 1 by 3 means, yes, 2 by 1 minus 3 z inverse. Now try to make this term as 0. Z inverse is equal to 2, you substitute. Hope you are getting these partial fractions. Good morning, Shashi. Now, after this, try to draw the pole 0 plot. And already we have seen that we'll take a polar plane Z, which is nothing but a Z plane here. So take a unit circle. Take a unit circle. ROC is drawn always with respect to unit circle. This is real part of Z, imaginary part of Z. Now, where are the poles located? One pole is located, always remember here coefficient of Z inverse indicate the pole. One pole is located at 0.5. Along the pole draw a dotted circle. The other pole is located at 3. Like this. Now you tell me, from this pole 0 plot, how many ROCs we can have? From this pole 0 plot, how many ROCs we can have? From this pole 0 plot, type your answers. How many ROCs you can have? Suppose if I have a situation like this, how many ROCs I can expect? 3 ROCs, exactly. What are those? Outside of the outermost pole, mod Z greater than 3. Inside of the innermost pole, mod Z less than 0.5, and between two poles, 0.5 less than mod Z less than 3. 3 ROCs. Now, come here. First case, if I take mod Z greater than 0.3, mod Z greater than 3. Mod Z greater than 3 means what is that ROC? This ROC, outside of the outermost pole. This region. See, when I am saying that this region means that region includes circles, concentric circles, right? Mod Z greater than 3. Now, for this ROC mod Z greater than 3, what happens to our system? What happens to the causality and stability? What happens to the causality and stability we have to observe. Now here, if I simplify this one, H of Z, Z inverse 3Z minus 4, if I take Z inverse common in the numerator, in the denominator if I take Z power minus 2 common, Z square minus 3.5Z plus 1.5. This is H of Z is equal to Z into 3Z minus 4 by Z square minus 3.5Z plus 1.5. Here numerator power is 2, denominator power is also 2. If you observe here, numerator power is 2, denominator power is also 2. Okay, well, and in the first case, ROC is outside it. Okay, ROC is outside of the outermost pole and the numerator power is equal to denominator power. So definitely mod Z greater than 3 corresponds to a causal system. Mod Z greater than 3 corresponds to a causal system. Later on we can verify also whether our assumption is correct or not. We can verify also by calculating the impulse response. That also we'll discuss. Okay, here rational transfer function, numerator power and denominator power are same and ROC is outside of the outermost pole, means definitely this corresponds to a causal system. Now stability also you have to verify. Now you see whether this ROC includes unit circle or not. You observe whether this ROC mod Z greater than 3 includes unit circle or not. Sorry, it doesn't include unit circle. So for this case, our system becomes causal, but it is unstable. If the ROC of your system function includes unit circle, then only it becomes stable. Right? For example, look here, if you have any doubt, suppose if I have a system function like this, z upon z minus 1 by 2 for mod z greater than 1 by 2. I have one more system function like this, z upon z minus 2 for mod z greater than 2. Suppose if I have these two system functions, now if you try to plot the ROC, take a unit circle, pole is located 1 by 2 along the pole toroid. So ROC is this one, mod z greater than 1 by 2, means definitely it includes unit circle. It is crossing the unit circle, ROC is crossing the unit circle. In the second case, what will happen? So this is real part of z, imaginary part of z. The pole is at 2. The pole is at 2. Now if you try to plot the ROC, ROC is what happened? Mod z greater than 2. It doesn't include the unit circle. In which case what happens? What is your conclusion? Here, if ROC includes unit circle, we'll call it as a stable LTI system. Here, this is unstable. Unstable. How can you say? Do one thing. Calculate the impulse response. What is the relationship between impulse response and transfer function or system function? Z transform. So inverse is 1 by 2 whole power n u of n. Here what is the impulse response? It is 2 raised to n u of n. If you try to plot this impulse response, 1 by 2 whole power n u of n impulse is a decaying exponential, no? Definitely this is absolutely summable. Absolutely summable. 2 power n u of n. This is growing exponential. Growing exponential. So not absolutely summable. So remember, if the ROC of your Z transform includes unit circle, then the system becomes stable, otherwise it is not stable, unstable. So utilizing this fact, causal, our system became causal and unstable. Second one, mod z less than 0.5. Mod z less than 0.5. Mod z less than 0.5 means this one, inside of the innermost pole. Inside of the innermost pole. Remember, if ROC is inside of the innermost pole, in that case it is anti-causal. Anti-causal. And mod z less than 0.5, does it include unit circle? No. So it becomes unstable. Unstable. Third case, 0.5 less than mod z less than 3 means from 0.5 to 3. From 0.5 to 3 means what is that portion? Here, this portion. From 0.5 to 3. From 0.5 to 3. So from 0.5 to 3, ROC is two-sided. Two-sided means, remember, it is non-causal always. Non-causal, and it is including unit circle. Stable. Including unit circle, stable. After this, let's find out the impulse response corresponding to this case. Impulse response corresponding to this case, and impulse response corresponding to the third case. What could be the impulse response corresponding to the first case? See, in the first case what happened? Both mod z greater than 3. Mod z greater than 3 means what? Both the poles, the pole at 0.5 and the pole at 3, both are outsided. So write the outside equivalents, inverse the transform. So what will happen? 2 by 1 minus 3z inverse. So it would be 2 times 3 power n u of n plus 1 times 0.5 whole power n u of n. Simply, I am not doing anything. I am writing the inverse Z transform so that I will get the impulse response. Now, if we observe here, u of n is there. So, this is starting at 0. This is also starting at 0. So, h of n is 0 for n less than 0. H of n is 0 for n less than 0, consistent with the statement that the system is causal. Right. Now, write for the second one in the similar fashion. Mod z less than 0.5 means what? See, because in exam they will ask what is the impulse response of the system if the system is anti-causal and unstable, non-causal and stable. He may ask anything. So, we must be in a position to get the inverse Z transform also. Right. Now, h of n for mod z less than 0.5. Mod z less than 0.5 means both the poles are inside it. Both the poles are inside it. Inside it means what is the inside equivalent? Already we have seen in the initial classes that a power n u of n, Z transform is z by z minus a, and minus a power n u of minus n minus 1, Z transform is also z by z minus a, but ROC for this one is mod z greater than mod a, ROC for this one is mod z less than mod a. Right. Now, write the inverse for this one. Minus a power n u of minus n minus 1 plus now you can observe here u of minus n minus 1, here also in both the terms u of minus n minus 1 is coming, means the resulting the signal impulse response exists from minus 1 to minus infinite, and clearly you can say that h of n is 0 for n greater than 0, which confirms that it is anti-causal. Now come to this case, non-causal. See here how you are going to write the inverse, from 0.5 outside it, from 3 inside it. Okay. So from 3 inside it, from 0.5 outside it. So your h of n would become 2 times minus 3 whole power n u of minus n minus 1 from 3 inside it and from 0.5 outside it. Okay. From 0.5 outside. So here clearly you can observe impulse response is existing both for n greater than 0 and n less than 0. So it is non-causal and it is stable as well here. Right. Please confirm up to this point so that I am going to make a statement now. All of you give your confirmation now so that I want to make a statement. Give your confirmation so that I am going to make one statement from this problem. Completed? Please give thumbs up if you are done. Today our session, I am going to take a long session. You must have patience today. Right, here, look here. We know that, observe here, we know that if we want to realize any system in practice, if you want, very important statement, listen, similar kind of statement I have done in Laplace also, remember. Okay. If you want to realize any system in practice, it must be causal and at the same time it must be stable. If you want to realize any, I repeat, if you want to realize any system in practice, it must be causal and at the same time it must be stable. So practical realization, causality must be achieved, stability must be achieved. But if you observe here, look here, stability is achieved in the third case, but the system is non-causal. Causality is achieved in the first case, but the system is unstable. Now we cannot do anything with the third case. I cannot do anything with the third case because non-causal systems we cannot realize. All physically realizable systems are causal systems only. Non-causal systems we cannot realize. If I want to do something, I have to do here only, because all physically realizable systems are causal system only. Now from the first case, when can this see causality is achieved means this can be physically realizable. So stability is lost. No, now let's search the condition for stability, right? Now when can this system become stable for this case? When can the system become stable for this case? Look here, observe the pole 0 plot. If the pole at 3, instead of being at 3, if it is inside the unit circle, the pole at 3, if it, instead of being outside the unit circle, if it is inside the unit circle, for the first case, what happened? Look here, for the first case, instead of this pole being outside the unit circle, suppose if the pole at 3 is inside the unit circle, what happened? I'm audible or not? Okay. See, instead of this pole at 3, instead of this pole at 3, instead of being at 3, if it is inside the unit circle, what will happen? ROC is anyway outside, and if this pole is inside the unit circle, it will include the unit circle also, in which case it becomes stable. See, the first case is like this. Observe here, the first case is like this. No, we took a unit circle, one pole is here, one pole is here. This is 0.5, this is 3. Now we got the ROC like this. We got mod z greater than 3 means we got the ROC like this. What I am saying is, if this pole instead of being at 3, if it is inside the unit circle, what will happen? ROC is anyway outside, so it becomes causal, and if it is inside the unit circle, it includes the unit circle also, in which case it becomes stable. Or can I say this statement like this? A causal means physically realizable rational transfer function. A causal rational transfer function becomes stable if all the poles lie inside the unit circle. A causal means physically, very important statement. A causal means physically realizable rational transfer function becomes stable if all the poles lies inside the unit circle. So let me write that statement. Very important statement. Note, a causal rational transfer function becomes stable if all the poles lie inside the unit circle. That is, the magnitude of the poles must be less than 1. Now if you remember, similar kind of statement I made in Laplace also. In Laplace, what I said? A causal rational transfer function becomes stable. Laplace, what I said? A causal rational transfer function becomes stable if all the poles lie on the left half of S plane, I said. If all the poles lie on the left half of S plane, here what I am saying, if all the poles lie inside the unit circle. So what is the condition I said there? See, the poles must have negative real parts I said. If you remember, the poles must have negative real parts I said. Here what I am saying, the magnitude of the poles must be less than 1. If the magnitude of the poles is less than 1, then only they can lie inside the unit circle. Unit circle. Very, very important statement. Pramod Kumar, I didn't get your doubt here. So this is a statement what we are going to make from this problem. Right. See, after this, let's take one more concept of the transform which is remaining, that is pole location, most probably tomorrow for electrical, and time domain behavior of causal signals. Pole location and time domain behavior of causal signals. Pole location and time domain behavior of causal signals. Observe here, what is the concept here? Look here, all of you. What is the concept? Sometimes in exam, what they'll do, you know, they'll give this kind of pole zero plot. They'll give this kind of pole zero plot. Some pole zero plot they'll give. They'll say that the pole is on the real axis between 0 and 1. They'll say the pole is on the real axis between 0 and 1. Now, what is the shape of the time domain signal? What is the shape of the time domain signal, they'll ask. What is the shape of the time domain signal? So, step by step, we'll try to get this concept. Very interesting. Observe here. In order to understand this concept, first of all, for causal signals only, the behavior of causal signals only we are going to verify. What is the Z transform for A power n u of n? It is Z by Z minus A mod Z greater than mod A. Observe here. Now, first case, suppose in exam they gave this kind of pole zero plot and they are asking you, in time domain, what is the shape of the signal? Then how you are going to proceed like this? Look here. See, say this is at 1 by 2. This pole is at 1 by 2 assume. Now here Z by Z minus A means here the pole is at A, no? Pole is at A. If I consider that A to be 1 by 2, what will happen to my signal? On the real axis between 0 and 1 means take some value 1 by 2, 1 by 3, 1 by 4, your wish. Now here I am going to take 1 by 2. 1 by 2 whole power in u of n. The corresponding time domain signal would be 1 by 2. So what will be the time domain signal? 1 by 2 whole power in u of n. So let me, so let this be A, Z by Z minus 1 by 2. So corresponding time domain signal is, corresponding time domain causal signal is 1 by 2 whole power in u of n. So you know right, what is the shape of 1 by 2 whole power in u of n? It is a decaying exponential like this. Fine. So if you are given a pole zero plot, now we are able to draw the shape of the signal. Now I'll change. Now I'll change the pole location. I'll change the pole location from here to here. I'll put here. Now what happened? this is z by z minus 1. Z by z minus 1. 0 is also there, but I am not indicating that 0. Z by z minus 1 means what is the inverse of z by z minus 1? U of n. U of n. Like this. In the third case, I'll move the pole here outside the unit circle. Say this is a 2. So here now my a value is 2. What will happen? The corresponding signal will be some 2 power n u of n. 2 power n u of n will be a growing signal like this, exponentially growing signal. Like this. Hope you understood. Please confirm so that I can go to the next part. Please confirm. See what will happen. The next case is what will happen if the pole is on the real axis between -1 to 0. Here, what happens if the pole is on the real axis between -1 to 0. So in this case, say this is -1 by 2. So the signal becomes -1 by 2 whole power n u of n. -1 by 2 whole power n u of n. So you try to draw the shape of the signal. If you give different values of n, the same shape as 1 by 2 whole power n u of n only will come, but with alternate plus and minus. 1 by 2 whole power 0 is -1 by 2 whole power 0 is 1, -1 by 2 whole power 1 is -1 by 2. Same shape will come, but with alternate plus and minus. Next case, now the pole zero plot what I am giving now is a previous gate question. They gave this one. What is the time domain signal shape? So here this would be, this is at -1, no, pole is at -1. So if pole is at 1 means u of n can be written as 1 power n into u of n. Pole at -1 means -1 whole power n into u of n. So its time domain equivalent will be like this. The same shape as u of n will get, but with alternate plus and minus. What happens if I am going to place the pole here? Say this is at -2. So the signal becomes -2 whole power n u of n. -2 whole power n u of n shape would be same as 2 power n u of n, but with alternate plus and minus. Please confirm. Shall I go to the next part? So if you are given a pole zero plot, now you are able to in a position to draw the shape of the signal also. You can notice one thing, that as the pole is moving away from the origin, it is losing its boundedness. Next, look here. The next situation could be like this. Here I am having a, look here, I am having pole at 1 by 2 on the real axis between 0 and 1, but of order 2. Two poles are there. Suppose if two poles are there, what could be the shape of the time domain signal? If two poles are there, what could be the shape of the time domain signal? For this, see, pole is on the real axis, say at 1 by 2, but of order 2. M is equal to 2 means two poles are there. For this, how to get the time domain signal? You have to use one more standard Z transform pair, that is n into a power n u of n. Do you remember what is the Z transform for n a power n u of n? Az by z minus a whole square for mod z greater than mod a. While discussing the differentiation in Z domain property, we have seen this. Mod z greater than mod a. Right? Say this is at 1 by 2, pole is at 1 by 2 of order 2. Order 2 means two poles are there. So the corresponding signal would be n times 1 by 2 whole power n u of n. Try to draw n times 1 by 2 whole power n u of n. Sir, how to draw? I don't know, sir. Means, array, give different values of n, you will get the shape of the signal. We are not doing any rocket science. Give different values of n. What happens if I substitute n is equal to 0, 0. N is equal to 1 means 1 by 2. N is equal to 2 means again 1 by 2. N is equal to 3 means this value will get decreased. So it will come like this. Very simple. Sir, what happens if I'm having, look here, if I move the pole on the unit circle of order 2, what could be the shape of the time domain signal? What could be the shape of the time domain signal? Here a value became 1, no. Here a value is 1 by 2 on the real axis. Here a value is 1. So nu of n. If nu of n, what is nu of n? Ramp signal in discrete. Ramp signal in discrete. Ramp signal in discrete. Like this. Nu of n. Now, what will happen if the poles are on the poles are outside but of order 2? Say this is at 2. Assume that this location poles are located at 2 of order 2, 2 poles. So a value is 2, n times 2 power n u of n. N times 2 power n u of n. N times 2 power n u of n means what could be that shape? Give different values of n. N is equal to 0, n is equal to 1, n is equal to 2, you put this kind of thing. Now, the next thing is here you may have this kind of situation. m is 2. What could be the time domain signal here? N times minus 1 by 2 whole power n u of n. What could be its shape in, or what could be its inverse Z transform? The same shape you will get as that of n into 1 by 2 whole power n u of n, but alternative plus and minus will come. Alternate plus and minus will come. The poles are located at z is equal to minus 1, 2 poles are located. So what could be the time domain signal shape? N into minus 1 whole power n will come. Alternate plus and minus. Here n times for this one, what will come? Minus 2 whole power n into u of n. So its time domain shape will be same as the previous one only. Previous one is this one, but with alternate plus and minus. Alternate positive and negative values. Please confirm. Please confirm. Shall I go to the next part? Please confirm. Harish, Aravind, Vamsi. Right. Next one. So in this way, you can draw the time domain signals. Now I am giving a homework for you. Homework is, I will give the pole zero plots. I will give the pole zero plots. You try to get the shape of the time domain signal like this. This is the first case. This is the second case. Third case. Okay. So what could be the shapes of the time domain signals you have to get? Homework. Homework. Right? See, one more 5 minutes concept is there in Z transform. After that, we'll start with Fourier series. Right? That is next concept. Listen carefully, all of you. Concentrate here. Concentrate here. The next concept is mapping S plane to Z plane. Mapping S plane to Z plane. Listen carefully, my dear students. Mapping S plane to Z plane. Mapping S plane to Z plane means, suppose if I take a point in S plane, what is the corresponding point in Z plane? See, in many situations you will have a requirement of mapping S plane to Z plane, especially for EC students in the realization of digital filters, especially IAR filters will have this kind of application. Where you have to map from S plane to Z plane, right? See, the design of IAR filters involves, first of all, we'll try to realize a equivalent analog filter whose poles and zeros will be lying on the S plane. After that, by using some transformations, we'll convert that analog filter to digital filters like impulse invariant or bilinear transformations we'll use. There, this mapping is very much useful. Or examination point of view also, mapping S plane to Z plane is very much useful, and there is a simple concept. This is a very simple concept. If you concentrate, you will definitely understand. Listen. So mapping S plane to Z plane means, suppose if I take a point in S plane, what is the corresponding point in Z plane? Suppose if I take left half of S plane, what does that correspond to in Z plane? Suppose if I take imaginary axis, what does that corresponds to in Z plane? If I take right half of S plane, what is the equivalent of right half of S plane in the Z plane we are going to consider now, right? Listen carefully. 5 minutes. It will take around 5 minutes. After that, we'll go to the next topic. For this, look here. If you want to map, listen carefully. Concentrate here. First of all, draw an S plane, which is a complex plane. Look here. I am drawing an S plane. Drawing an S plane. S plane I took. Complex plane. Sigma j omega. Okay, S plane. And Z plane you take. Z plane you take. Z plane is a polar plane. Okay. So this is a unit circle, real part of Z, imaginary part of Z. Now I don't need this heading anymore. I don't need this heading. I'm removing the heading, right? So S plane I took, Z plane also I took. I think you understood the idea. Suppose if I take a point in S plane, what is the corresponding point in Z plane? Remember, the relationship between Laplace transform and Z transform, or the relationship between S plane and Z plane, or the relationship between analog frequency and digital frequency, is given by Z is equal to e power st. Remember this relation. Z is equal to e. This is a relationship between Laplace transform and Z transform. Z is equal to e power st. How this came, we are not concerned. Okay, there is a small proof, but we are not concerned with, where t is the sampling period. Here, t is known as sampling period. Sampling period is nothing but distance between adjacent samples. Z is equal to e power st. First of all, forget about mapping. You remember this relation. Z is equal to e power st. After remembering this, now we know that S is equal to sigma plus j omega. S is equal to sigma plus j omega. Now substitute S is equal to sigma plus j omega in this relation. Z is equal to e power st. S is equal to sigma plus j omega. What happens to your Z? E power sigma plus j omega into t. Sigma plus j omega into t. Or how can I write this one? E power sigma t times e power j omega t. Can I write like this? Yes. Where the magnitude of Z is e power sigma t. Phase of Z is nothing but omega t. Right. After knowing this one, let's start mapping. Let's start mapping. First of all, what I'll do is case 1 I'll take. Case 1, case 2, case 3. Case 1. Listen carefully. Listen carefully. Case 1. Case 1 is, see, in statements also we can give, but let's do some experiment. Case 1 is sigma less than 0. Sigma less than 0. See, in S-plane, sigma less than 0 means what, you know? This portion. This portion. Sigma less than 0 means left half of S-plane. Sigma less than 0 means, right, left half of S-plane. So first of all, we will observing left half of S-plane is mapped to what region in the Z-plane? Left half of S-plane is mapped to what region in the Z-plane we are observing. For that, look here, do one thing. Sigma less than 0 means, see, take some value of sigma. Take some value of sigma. Which color? Black color. See, sigma I am considering to be minus 0.5. Sigma consider him to be minus 0.5. Right? Now, what I am going to do is, here I am going to consider a strip here. Observe here, I am going to consider a strip. So, see, along with the values of sigma, I must vary the values of omega also, right? Along with the values of sigma, see here, if I take one point, look here, if I take some point here, this corresponds to real part as well as imaginary part. So, along with the values of sigma, I must consider the imaginary values also. So, my consideration is from minus j pi by t, observe here, minus j pi by t to j pi by t. Why these strips are means, let's understand. Minus j pi by t to, for the time being, minus j pi by t to j pi by t. Okay, I am considering only in this portion, minus j pi by t to j pi by t. What is the width of this strip? If I call this as strip, what is the width? Width is 2 pi by t. Minus j pi by t to j pi by t means what is strip? What is the omega is varying? What is the variation in omega? 2 pi by t. 2 pi by t. Observe here. Look here, sir. Sigma value I took as minus 0.5. Right? Now let's map. Now I am going to take the first point here. Look here. Let's map this point. What is this point? Can you tell me? Minus 0.5. As well, minus 0.5 minus j pi by t. Agreed? This point is minus 0.5 minus j pi by t. Right? Now what happens if I substitute that value in this relation? So the first one I am going to take, I want to map this point, minus 0.5, look here, minus 0.5 minus j pi by t. Z is equal to e power st relation is there, no? Substitute, very simple, sir. Z is equal to e power st. Substitute e power minus 0.5 minus s value is minus j pi by t multiplied with t, or z is equal to e power minus point t into e power minus j pi, e power j pi, right? So magnitude of z will be what? E power minus 0.5 t. Magnitude of z will be e power minus 0.5 t, and phase of z will be minus pi. Now can you locate this point in the z plane? See, mod z is equal to minus 0.5 t is anyway a circle of radius e power minus 0.5 t. You take any value of t, you take any value of the sampling period t here, this value will be less than 1. Where you are going to locate this one? So this value is some value less than 1, but at an angle of minus pi. Angle of minus pi means, look here, this is 0, this is pi by 2, this is pi, this is 0, this is minus pi by 2, minus pi, right? So if the corresponding point to minus 0.5 minus j pi by t is what? This value at an angle minus pi, I must get this one, no? E power minus 0.5 t, or if you are not feeling comfortable, take the value of t to be 1 also, no problem. So e power minus 0.5 is a value less than 1, where you are going to locate at an angle of minus pi means here. So this point minus 0.5 minus j pi by t is mapped to this point in the z plane. After this, take the next point, look here, take this value and try to map that on the z plane. You will get here, somewhere here. Again take next point, you will get somewhere here. Take next point and go on, like doing like this. So if you are going to map, the corresponding points will come like this, right? Now by the time you reach this, here if I reach the point minus 0.5, here omega value is 0, no? Suppose what happens here, z is equal to, suppose if my s value is only minus 0.5, sigma value is omega value is 0, means what happens, z is equal to e power st. So e power minus 0.5 t, angle is 0, e power minus 0.5 t, here angle is not there means 0. Listen carefully, angle is not there means minus, z is equal to e power minus 0.5 t, angle is 0. This distance is, look at this distance is e power minus 0.5 t. Now again I reached here, again go on increasing the values of omega. If you go on increasing the values of omega, again you'll reach the point where you started. So this is the mapping, right? Hope you understood. After that, see, after the class you have to do experiments, otherwise you won't understand. If I give the statements, definitely you will try to mug up and all, but that is not a good practice. After that, do one thing, you take the value of sigma to be minus 1, and go on giving different values from this value to this value. Look here, go on increasing the values of omega from minus pi by t to pi by t. Eventually the next mapping will be like this. You take minus 2, again you will get one more circle inside the z plane. Hope this is comfortable. If this is comfortable, I will make the statement. If you are comfortable, I will make the statement. Please reply. Reply so that I can make the statement. Now you are able to successfully map or take the location of any point and substitute in z is equal to e power st. That's it. Please reply. Take any point in the S-plane and try to substitute that in z is equal to e power st. And take the strip length, vary the values of omega from minus j pi by t to j pi by t. Please reply. Nobody is giving reply. What happened here? Now look here. You can ask one thing, sir, what happens if I increase the values here? What happens if I increase the values here? Omega value we increase from minus pi by t to pi by t only. Now what happens if you increase the value of omega? Remember students, if you increase the value of omega from j pi by t to some, if you are going to this point j 3 pi by t, where again the difference is 2 pi by t, it is not, if I give the statements, it definitely will understand, nothing is there here. Now look here, if I am going to increase the values of omega from pi by t to some j pi by t to 3 pi by t, taking the values of sigma as minus 0.5 only, what will happen? Again I am going to get the same, we are going to trace the same circle as we have done before. Look here, periodical nature will come. Suppose if I am going to vary the values of omega from pi by t to 3 pi by t, again which is a strip of length 2 pi by t, again we are going to trace this circle like this. Again we are going to get like this. Here also if I am going to vary the values of omega, again we are going to get this circle only in the z plane. So this is what is known as, look here, primary strip will call. The strip from minus j pi by t to j pi by t is called primary strip. What it is known as? Primary strip. Primary strip. Primary strip. And the strip from j pi by t to j 3 pi by t is called complementary strip. Complementary strip. Complementary strip. Right. Now look here. So can I give the statement now? Now observe the statement. Now observe the statement. Sigma less than 0. What is the statement I am going to make? The statement is like this. What happened here? Sigma less than 0, what is your notation? If you are going to take the values of sigma less than, simple, sir, simple sense also we can make. Generally, the statement is the left half of S plane, simple statement is the left half of S plane is mapped to inside the unit circle, right half of S plane is mapped to outside the unit circle, and imaginary axis is mapped on the unit circle. Simple statements also we can give. See, if you refer any book, we will have simple statements only, that left half of S plane is mapped to inside the unit circle, right half of S plane is mapped to outside the unit circle, imaginary axis is mapped on the unit circle. But there are some constraints, so I am trying to explain those constraints, right here. Now you have observed one case, no? Now what is that I am going to write here? Case 1, I am going to make one statement here. Look here, case 1, sigma less than 0, strips of width, look at strips of width. What is the width of the strip we took? Primary strip, what is the width? 2 pi by t. Strip of width 2 pi by t in the left half of S plane, in the left half of S plane are mapped, where it is mapped? Are mapped to the interior of the unit circle, to the interior of the unit circle. And what happens if I am going to increase the values of omega? Again we are going to trace the same circle as we have done before, no? So I'll write here over and over. I'll use one word, over and over. Over and over. Or if you can understand this one, the same thing will happen for sigma greater than 0, but outside the unit circle. The same situation will come outside the unit circle. Case 2. Look here, case 2. Case 1 is completed. Case 2. Case 2 is what happens if sigma greater than 0. What happens if sigma greater than 0? Do one thing. Sigma greater than 0 means take some value here 0.5. Proceed with the same. Increase the value. See, increase the values of omega from this value minus pi by t to plus pi by t. I am giving cross sign. It doesn't indicate the pole. Right? Now, that will be mapped outside the unit circle. See, if I am going to take the values of sigma less than 0 and I am going to consider a strip of width 2 pi by t, I am going to get the circles inside the unit circle. Now, for this case, we will get circles over and over means repeated. Vamsi Krishna, repeated. Because if I am going to increase the values of omega from pi by t to 3 pi by t, again the same circles what we have what we came across, they will get repeated. So over and over, over and over. In Telugu, malli malli. In Hindi, bar bar. Okay. Now, what happens if I take the values of sigma greater than 0? You can test also. Look here, sigma greater than 0, you take sigma value 0.5. Now you start from this location, from here bottommost minus j pi by t omega value. Okay, so S is equal to minus 0.5 minus j pi by t. Same procedure, minus j pi by t. Z is equal to e power st is the relation. Z is equal to e power minus 0.5 minus j pi by t multiply with the t. After the class, you do one thing, take the value of t to be 1 and verify. E power minus 0.5 minus 0.5 t minus what will come here? E power minus j pi. So this is magnitude, this is phase, right? Oh, 0.5, no? This is 0.5 plus 0.5 plus 0.5 plus 0.5, right? Now, magnitude of z will be e power 0.5 t, phase of z will be minus pi. So for this value where you are going to get the mapping on z plane, e power 0.5 t, always its value is greater than 1. Its value will be greater than 1 but at an angle of minus pi. So this point in S plane corresponds to a point e power minus 0.5 t at an angle minus pi in z plane. Exactly. So here if I take this point, so this will be mapped somewhere here. E power 0.5 t is a value greater than 1 at an angle minus pi. Again go on increasing the values of omega from minus pi by 2 pi by t. So you will get this kind of situation. right half of S plane, if you consider any point, that will be mapped outside the unit circle. You are going to get circles outside the unit circle. Hope this is clear. Now after that you take the value of sigma to be 1. Again increase the values of sigma. What happens if you cross this primary strip? What happens if you cross this primary strip? Periodical nature. Periodical nature. Again we are going to trace the same circles over and over, over and over. Now can anybody tell me, if I am going to increase the value of omega from minus infinite to plus infinite, how many times we are going to trace the circles in the z plane? My question is, if you are going to increase the values of omega from minus infinite to plus infinite, how many times we are going to trace the circles in the z plane? How many times? How many times? I am increasing the values of omega from minus infinite to plus infinite. How many times we are going to trace the circles in the z plane? Due to periodical nature, infinite number of times. Very good. Infinite number of times. Infinite number of times we are going to trace. So what is the statement you are going to give? Here, what is the statement we gave in the second case? Strips of width 2 pi by t in the left half of S plane are mapped to the interior of the unit circle. Okay. Right half of S plane. Strips of width 2 pi by t. What is that you are going to give? In the right half of S plane, are mapped to the exterior of the unit circle, to the exterior, outside the unit circle, exterior of the unit circle. How many times? Infinite number of times, over and over, over and over. If you are going to cross the primary strip, means definitely you are going to have the same encirclements over and over. Yes, infinite number of times. See, for example sake, I have taken one value of S. After the class, you can take any, you take different values of S and experiment. If I say something, you follow after the class, you must experiment, otherwise your subject will not improve. Your analytical thinking will not improve. See, I can make simple statement that left half of S plane is mapped to inside the unit circle, right half of S plane is mapped to outside the unit circle, and imaginary axis is mapped on the unit circle, but that doesn't make any sense. Right. Again, you can increase here the values of omega. If you increase, see, the circle which we got by taking sigma is equal to 1, the same will be traced one more time. Again increase one more time. So the infinite number of times we are going to have the encirclements. Right. Now case 1, case 2 is completed. Last case is there, chota bacha case, that is case 3, sigma is equal to 0. Case 3, if this case is completed, we can complete this Z transform. Sigma is equal to 0. Sigma is equal to 0. Any guess? Sigma is equal to 0. Again you have to increase here. Look at sigma is equal to 0 means this value, substitute this value, this value. You have to consider the primary strip from minus j pi by t to, what happens? If you are going to take different values, we will get them on the unit circle. Unit circle. Now if you observe, I am using the same symbols. What are the symbol I am using in S plane? Corresponding symbol I am using in Z plane also. That's it. What happens if I go beyond j pi by t? So the same unit circle will be traced. So here also if you are going to if you are going beyond j pi by t, your unit circle will be traced infinite number of times, infinite number of times. So case 3 directly I am giving the statement, strips of width, strips of width 2 pi by t of the j omega axis are mapped onto the unit circle. Hope this is clear. If you want to remember in a simple sense, left half of S plane is mapped to inside the unit circle, right half of S plane is mapped to outside the unit circle, imaginary axis is mapped on the unit circle or AR. It is evident. It is evident. It is evident. After the class, work with this one. Definitely you will get mistakes. Learn from the mistakes. Primary strip means minus pi by t to omega value varying from minus pi by t to pi by t. Primary strip width is 2 pi by t. Now remember one thing. Look here. Before leaving this topic, one statement I want to say. Now you please tell me whether I am right or wrong. See, mapping means generally we look for whether the mapping is 1 to 1 or many to 1. Now can I say that the mapping in the primary strip is 1 to 1. The mapping in primary strip is 1 to 1, whereas the mapping in the complementary strips is many to 1. Can I say that? Please reply. I am going to get 1 to 1 mapping in the primary strip only. I am going to get 1 to 1 mapping. See, we are mapping S plane to Z plane, no? 1 to 1 corresponding to a value of S, I am getting a value of Z in the primary strip only. Because if I cross this primary strip, in the complementary strips I am going to get the same values, means in the complementary strips I am going to have many to 1 mapping. So here we can make one statement that 1 to 1 mapping, very important statement, 1 to 1 mapping between S plane and Z plane, between S plane and Z plane is possible in primary strip only. Is possible in primary strip. For EC student, this statement is very useful when you are realizing digital filters. 1 to 1 mapping between S plane to Z plane is possible in primary strip only. Am I correct? Right. So this is all about your Z transform. Now let's start with continuous time Fourier series. Continuous time Fourier series. And one more thing is, my dear students, I have a question for you. In the previous one, here this origin is there, no? 0 plus j0. You please verify where it is mapped to the corresponding point in the z plane. This point is there, no? Homework is 0 plus j0 is there. So it is corresponding to what point in this z plane? If you are not getting, I'll explain tomorrow. Using the concept what I told you, you take the point in S plane, that is 0 plus j0, and you verify to which point it is mapped in the z plane. Okay, continuous time Fourier series. See, before going to this continuous time Fourier series, you must understand some concepts. I don't know whether you remember or not. While discussing periodic signals, we have seen what is the principle of orthogonality. Principle of orthogonality. You do, Vamsi. Tomorrow I'll tell you, don't worry, I'll tell you tomorrow. In tomorrow's class I'll reveal. I told you one concept, with that you try. Thank you, Nagesh. Look here. Principle of orthogonality. See, this Fourier, before going to understand this Fourier series, you must understand this principle of orthogonality also. See, when can you say that two signals are orthogonal? There must be a condition, no? So, two signals, and how we are going to use this orthogonality principle in Fourier series also will observe. Two signals x1 of t and x2 of t are said to be orthogonal. Are said to be orthogonal when if you multiply the signals and integrate, means take the area under the signal, and if that results in 0, then they are said to be orthogonal for aperiodic signals. For aperiodic signals. And for periodic signals, see, take one period. In that period, multiply the signals. If the signals are periodic signals, when can you say that they are orthogonal? Multiply the signals and calculate the area over one period. Integration means area. If that results in 0, then they are said to be orthogonal for periodic signals. Very, very important concept. Important concept. This is required for Fourier series. Today I am going to extend the class up to 10 o'clock. 1 more hour I am taking. If you want any break, relax and come for 1 or 2 minutes. See, two signals are said to be listen like a story. See, Fourier series, listen like a story. We won't solve the problems, we'll play with the problems. Let's play with the problems. And I made a after the class I made one video also on this Fourier series using Python. See, there I explained everything, how a periodic signal is formed by adding different harmonically related orthogonal sinusoids. So after the class you watch the video, then you have clear clarity. Generally people will feel difficulty with this Fourier series, but nothing is there here. Nothing is there. Listen like a story now. So I started the story like this now. First of all, orthogonality we are looking at. So two signals, this is the definition for orthogonality. Why we are discussing the concept of orthogonality, we will observe. Right. After this one, let's take some important trigonometric relations. Important. Hope you understood the concept of orthogonality. If you are not able to, cope up with that Z transform, forget about that Z transform, nothing is there in that. Now, freshly concentrate on Fourier series. After the class, you can verify that Z transform, S plane and Z plane mapping. important trigonometric identities I'll put here. First one, over the period t, sine m omega naught t plus phi dt is 0. Here m is an integer. If m is an integer, see, if you can integrate over a period for this signal, it will be 0. This you already know. Some identities over the period t, where omega naught is 2 pi by t. In the same way, cos omega naught t plus phi, Fourier series is very easy topic, 0. If you understand in a proper way, Fourier series is deadly easy topic. Here over the period t, these identities you can prove after the class. Generally after the class you will feel bored, no? Then you can prove all these identities. Now fifth one, from the fifth one, every identity is important. Okay. Over the period t, sine m omega naught t plus phi 1 into sine n omega naught t plus phi 2 dt is 0. Dt is 0. Understand the fifth identity. Observe here what you are going to understand, because this orthogonality is very important to understand the trigonometric Fourier series. Look here. Here what I said, orthogonality I said. Orthogonality means for periodic signals, if you multiply the signals and calculate the area over one period, if that results in 0, then they are said to be orthogonal, x1 and x2. So here I am taking two sine signals but different frequencies. M omega naught, n omega naught means they will have different frequencies. Now I am multiplying the signals and integrating. Now can I say that these two signals are orthogonal? Can I say that sin m omega naught t plus phi 1 and sin n omega naught t plus phi 2 are orthogonal? Yes, they are orthogonal. They are orthogonal. So if you have two sine signals, if they have different frequencies, sorry, here this is orthogonal, m not equal to n, condition is there. If they have different frequencies, then they are orthogonal. Two sine signals are there. Two sine signal, one sine signal, other sine signal is there. When can you say that these two are orthogonal? Means if they have different frequencies, m not equal to n. Similar kind of statement. Suppose if I have two cos signals, if I have two cos signals, now I am multiplying those two cos signals and integrating over one period, and that is coming to be 0, means they are orthogonal, and this is also possible if they have different frequencies. Remember in first unit we studied that whenever if two power signals are orthogonal, you can add the powers. If two energy signals are orthogonal, you can add the energies. Remember, you can add the energies if the signals are orthogonal. If you can add the powers also if they are orthogonal, right? Suppose if your given signal is linear combination of two sinusoids, they'll ask what is the average total power. You observe whether they are orthogonal or not, then only you can add energies also. So if I have two sines, they are orthogonal if they have different frequencies. Two cos, they are orthogonal if they have different frequencies. Now what happens if one sine is there, one cos is there? Cos m omega naught t plus phi 1 into sine n omega naught t plus phi 2. is equal to 0. Is equal to 0 I kept means what? Cos m omega naught t plus phi 1 and sin n omega naught t plus phi 2 are orthogonal. When they are orthogonal, if m not equal to n, if they have different frequencies, they are definitely orthogonal. And they are orthogonal if they have same frequencies and same phases also. They are orthogonal if they have same frequencies and same phases also, they are orthogonal. Right? So if you have a cos signal, if you have a sine signal, if they ask you to calculate the total power, observe whether they are orthogonal or not. If they are not orthogonal, you have to go by different means. Here I am not going to look at the power and energy calculations. Already we did in the first unit. You can refer that video. Suppose if I have this relation. See here in the 8th one, I am taking a DC, A means a DC signal, and I am sinusoid I am taking. DC and sinusoid are also orthogonal. DC and sinusoid are also orthogonal. DC and sinusoid are orthogonal. DC and sinusoid are orthogonal. Orthogonality condition is must for Fourier series. Orthogonality condition is must for Fourier series. DC and sinusoid are orthogonal. Right. Hope everybody is comfortable with the principle of orthogonality. We are not going to look at the examples because our main concentration will be on Fourier series. First concept you must understand in Fourier series is orthogonality. Right. Let's start with the Fourier series. Again I am putting continuous time Fourier series. What is the purpose of continuous time Fourier series? First of all, why we are studying this continuous time Fourier series? Continuous time Fourier series is used for finding the frequency content of continuous time periodic signals. Continuous time periodic signals only. Continuous time periodic signals only. Used for finding the frequency content of continuous time periodic signals only, because continuous time Fourier transform, if you take, it is used for finding the frequency content of periodic as well as aperiodic signals, but this Fourier series is exclusively used for periodic signals. Now in this, what we are going to do, we are going to have this one. Fourier series gives the representation of, listen here, the representation of a periodic signal, representation of a periodic signal, representation of a non-sinusoidal periodic signal in terms of harmonically related mutually orthogonal sinusoids or complex exponentials. This is the purpose of Fourier series. See here, the purpose of Fourier series is we are going to break a periodic signals into different sinusoids. We are going to break a non-sinusoidal periodic signal into different sinusoids or complex exponentials. See, in Fourier series, what we are going to do is we are going to break the non-sinusoidal periodic signals in terms of harmonically related, mutually orthogonal sinusoids or complex exponentials. How that is going to happen, I'll let you know. So for this, here we are having two types of Fourier series. First one is trigonometric Fourier series and exponential form of Fourier series. First one is trigonometric Fourier series. See, Fourier series concept, if you want to understand in simple, in one statement, we can say that we can build any periodic signal. See, we can build any non-sinusoidal periodic signal. See, the other way also we can say here, we can build any non-sinusoidal periodic signal using harmonically related, mutually orthogonal sinusoids or complex exponential. That is also the best statement I can give. Let me give the statement. We can build a non-sinusoidal periodic signal, using weighted sum of harmonically related sinusoids or complex exponentials. This is the best statement. Any non-sinusoidal periodical signal can be obtained by weighted sum of harmonically related sinusoids or complex exponentials. By adding different sinusoids in different ways, we can build any periodic signal. Here, trigonometric Fourier series we are discussing now. So, in trigonometric Fourier series, the representation is given like this. How a periodic signal can be broken into the harmonically related mutually orthogonal sinusoids means like this: A naught plus summation n varying from, here x of t is a periodic signal. Observe here, x of t is equal to A naught plus summation n varying from 1 to infinite an cos n omega naught t plus bn sin n omega naught. This is the representation of a non-sinusoid periodic signal in terms of trigonometric Fourier series. Now, if you observe here, what happens if I expand x of t is equal to, observe here. Now look here, now concentrate. A naught is a DC value. A constant, plus what happens if I substitute n is equal to 1? A1 cos omega naught t. Now, if you observe DC and sinusoid, they are orthogonal. Plus, what happens if I substitute n is equal to 2? A2 cos 2 omega naught t. Here, A naught and see the first term and second term are orthogonal, the first term and the third term are orthogonal, second term and first term are orthogonal, second term and third term are orthogonal, third term and first term are orthogonal, third term and second term are also orthogonal. Now if you observe in trigonometric Fourier series expansion, every term is orthogonal with the other term. Every term is orthogonal with the other term. If you have that kind of situation, then you can build any periodic signal. Plus A3 cos 3 omega naught t. Now the fourth term is orthogonal to the rest of the terms and so on. If you find this kind of orthogonal sinusoids, mutually orthogonal sinusoids and harmonically related, one more word also, harmonically related, that also I'll explain. Harmonically related, I'll explain. If you have that kind of sinusoids, by adding or subtracting or doing some operations, some experiments on those kind of sinusoids, you can build any periodic signal. That's what is Fourier series. So on, plus B1 sin omega naught t. Now this B1 sin omega naught t is orthogonal with the rest of the terms in the expansion. Plus B2 sin 2 omega naught t. Now this B2 sin omega naught t is orthogonal with the rest of the terms in the expansion. You can observe. Plus so on up to Bn sin n omega naught and so on. So look here, we can build a non-sinusoidal periodic signal using weighted sum. Weighted means multiplied. Weighted means multiplied here. Weighted means weighted sum of harmonically related sinusoids or complex exponentials. See, Fourier series tells us how to build a periodic signal from sinusoids. In short, how you are going to build a periodic signal from sinusoids. In a nutshell, Fourier series means how to build a periodic signal from sinusoids or complex exponentials. Here, observe here, omega naught is given by 2 pi by t. Omega naught is given by 2 pi by t, which is known as fundamental. This is also known as fundamental. Fundamental or first harmonic, we will call. Fundamental or first harmonic. And multiples of fundamental are known as harmonics. Multiples of fundamental are known as harmonics. Suppose if I put n is equal to 1, this becomes omega naught corresponding to first harmonic. If I put n is equal to 2, this becomes 2 omega naught corresponding to second harmonic. And so on. N omega naught means nth harmonic. Nth harmonic. N omega naught means nth harmonic. Now if you observe here, cos omega naught t, this corresponds to fundamental. 2 omega naught is there, so this corresponds to first harmonic, second harmonic, this second harmonic, third harmonic, and so on. So the sinusoids, what you are going to use to build a periodic signals, what conditions they must satisfy, tell me. First of all, they must be orthogonal. Okay. And what is the other condition? They must be harmonically related. Harmonically related means, observe here, cos omega naught t, cos 2 omega naught t, cos 3 omega naught t, they are harmonically related, no? So if you have that kind of sinusoid, those kind of sinusoids, you can build a periodic signals by adding or subtracting and doing many ways. Hope you understood. Please reply. Right, here the main challenge in our trigonometric Fourier series is to find out this A0, AN, BN values. We have ready-made expressions to find out A0, AN, BN values. I am not going to prove those how those results came directly. I am going to give A0 is given by 1 by t over the period minus t by 2 to t by 2 x of t dt. This is also known as DC value. A naught is also known as DC value or average value. A naught is also known as DC value or average value. AN 2 by t integral minus t by 2 to t by 2 x of t cos n omega naught t dt. Bn value 2 by t the period minus t by 2 to t by 2 x of t sine. Remember, if you have harmonically related mutual orthogonal sinusoids, yes, you can construct any periodic signal. You can construct any periodic signal. So the first point you must understand is what is the purpose of Fourier series. The purpose of Fourier series is we can construct any periodic signal from harmonically related mutually orthogonal sinusoids. So the first concept is trigonometric Fourier series. What is the expansion here? This is the expansion. A naught plus summation n varying from 1 to infinite an cos n omega naught t plus bn sin n omega naught t. Here a naught, an, bn. Here a naught, an, bn are known as trigonometric Fourier series coefficients. A naught, an, bn are known as trigonometric Fourier series coefficients. How to find out the trigonometric Fourier series coefficients? A naught can be calculated like this, an can be calculated like this, bn can be calculated like this. We have expressions also. If you take one example, you will better understand. In that, what sinusoids are there with what frequencies. So how we are going to add and how we are going to get the resulting signal, you will understand. And but before that, the next concept is symmetry. Symmetry. Symmetry means we have some discounts here. Discounts. Discounts means the given periodic signal may be an even signal or it may be an odd signal. Suppose if your signal is even signal. For even signal, suppose if your signal is even signal, DC value A naught is optional. It may exist or it may not exist. A naught is optional. AN exists. For even signal, AN exists and BN is 0. So you have a discount for even signals that you need not calculate the value of BN. You need not calculate the value of BN. You have a discount that for even signals BN is 0. Simply you can verify also. Look here. BN, why it is 0? Signal is even. Sign is odd. Even into odd, odd. Minus t by 2, t by 2 means you are calculating the area from minus t by 2, t by 2. Area under the odd signal will be 0. This is for even signal. Next, discount for odd signal. For odd signal, A naught and AN are 0. Flat 50% discount. Festival offer is there here. A naught and AN are 0. A naught and AN are 0. BN exists. BN exists. BN exists. Means what? For even signals, look here, Bn is 0 means for even signals we don't need any sign terms. Generally in even signal we don't need any sign terms. For odd signals we don't need any cost terms. Cost terms. If you want to build an even signal, sign terms are not required because Bn is 0. For if you want to build, I mean if you want to build an odd signal, only Sine terms are required, right? So this is a discount, and after this I'll take one periodic signal like this. Okay, I took one periodic signal like this. Some periodic signal I am taking. Now if you observe, can you tell me what is symmetry? Is it an even signal? No. Is it an odd signal? No. Yes or no? Okay, this is not an even signal, this is not an odd signal. This is 0, this is t by 2, this is t I'll call, this is minus t by 2, minus t. This is what kind of signal is this one? But this is neither even nor odd. Symmetry is not there. Symmetry is not there. Say amplitude is A, if I call it as amplitude is A, this is minus A. Symmetry is not there, but some kind of symmetry must be there. Let's get that symmetry. Now this is x of t, no? Now can you get what is x of t plus t by 2? Can you draw? What could be x of t plus t by 2 from this signal? X of t is given. Sometimes we have to build these kind of signals also from sinusoids. Remember, we must build these kind of signals also from sinusoids. So we are understanding the nature. Now this is a signal x of t, x of t plus t by 2. X of t plus t by 2 means we know it is an advanced version, no? X of t plus t by 2 means advanced version. Advanced version means left shift. So simply shift left this signal by t by 2. Shift left this signal by t by 2. Okay, what will happen if I shift left? Okay, I'll get signal something like this. You also must try parallelly. This is x of t plus t by 2. Suppose if I ask you what could be minus x of t plus t by 2? Minus x of t plus t by 2 means to this x of t plus t by 2 take the amplitude reversal, means mirror image along horizontal axis you take. Mirror image along horizontal axis. What will happen? This is the signal what we are going to get. Is it same as the original signal what I took? Is it same as the original signal what I took? Yes, of course. So remember signals which satisfy this kind of property. X of t is equal to minus x of t plus or minus t by 2. X of t is equal to minus x of t plus or minus t by 2. They are known as half wave symmetry signals. What are these known as? Half wave symmetry. Half wave symmetry. How to verify whether signal is half wave or not with the best procedure I will tell you, don't worry. But before that you understand what is half wave symmetry. A signal, if it wants to be half wave symmetry, it must satisfy this condition. X of t is equal to minus x of t plus or minus t by 2. See what is the discount? Look here, for even signals what is the discount we got? For even signals Bn is 0, okay. For odd signals 50% discount, A0 and An are 0. But if the signal is half wave symmetric, suppose if your signal is half wave symmetric, do you have any discount? Yes. Fourier series coefficients exist only for odd harmonics. Here half wave symmetry signal A0 will be 0, A0 will be, DC value will be 0, and Fourier series coefficients exist only for odd harmonics. Only for odd harmonics. Fourier series coefficients exist only for odd harmonics, means in the resulting Fourier series expansion you will have omega. Odd harmonics means what? Odd harmonics. Harmonics is multiples of fundamental, omega naught, 3 omega naught, 5 omega naught kind of things you will have. Remember, if the signal is half-wave symmetric, in that A naught will be 0 and Fourier series coefficients exist only for odd harmonics. Odd harmonics. Right? Now, look here, sir. Generally, most of the students will confuse, sir, how to understand, how to identify whether signal is half-wave symmetric or not. How to understand by looking at the signal, how to understand whether signal is half-wave symmetric or not. I'll tell you with an example. Look here. I'm taking an example here. A periodic signal I am taking. A periodic signal I am taking like this. Mind me if the shape is not proper. Look here. Suppose if I have a periodic signal like this. Say this is 0, this is 1, this is 2, this is 3, this is 4, this is -1, -2, -3. -2, -3. -4, this is 4. Observe here. Now I want to verify whether this signal is half-wave symmetric or not. I want to verify whether this is a signal is half-wave symmetric or not. Now what is the condition for half-wave symmetric? X of t is equal to minus x of t plus t by 2. Now do one thing. Do one thing. So take one point. Here, observe here. In order to verify half-wave symmetry, take one point. Say 0.5 I am taking. Take one point, that is 0.5. What is the value at 0.5? What is the value at 0.5? 1. What is the value at 0.5? 1. To this 0.5, add or subtract half of the period. Add or subtract half of the period. Here what is the period? What is the period? Period means repetition. Shape at 0 is repeating at 4, no? So here period is 4. So half of the period will be 2. Now do one thing. Take one point as your wish. I took 0.5. Add the half of the period. What happens if I add or subtract also? You can subtract half of the period. So 2.5. Here t plus or minus, here t plus or minus will come. So what happens if I add 2.5 came? Now this 2, observe the value of the signal at 2.5. 2.5 means it will be somewhere here. What will the value at 2.5? It is -1. If the value at 0.5 and the value at 2.5, if they are equal and opposite, yes, this is half-wave symmetric. And of course this is even also, even plus half-wave. What I am saying, take some point as your wish, add or subtract half of the period to that point and observe the values at the 2 points. If they are equal and opposite, yes, your signal is half-wave symmetric. Half-wave symmetric. I will take one more example. So this is 0, this is t by 2, this is t, minus t by 2 and so on. Now I want to verify this is half-wave symmetric or not. Take one, what is the period first of all? What is the period here? Period is t. Period is t. Period by 2 is t by 2. Period by 2 is t by 2. Now take one point. Now what I am going to take is t by 4 I am taking. Say this value is a, this value is minus j. Now t by 4 I am taking. T by 4, what is the value? A. Now to this t by 4, add half of the period, or you can subtract half of the period. What happens if I add half of the period. T by 4. 3t by 4. Now 3t by 4 will be somewhere here. What is the value? Minus 3. So the value at t by 4 and 3t by 4 are equal and opposites. Yes, this is half wave symmetric. Half wave symmetric, but this is odd and half wave. This one is even and half wave. Even and half wave. Right? In the same way, you can observe this one also. This one, whether this is half wave symmetric or not, how to verify? How to verify? You take some point. You take some point here, observe that value and take half of the period, add or subtract that half of the period and observe the value at that point. Right. Hope you are comfortable. Right. So if the signal is half wave symmetric, the Fourier series coefficients exist only for odd harmonics. So in half wave symmetry signals we can have an also we can also have Bn, but that An Bn will exist only for odd harmonics only. Odd harmonics will only be present. Right. Now the next discussion is a signal being half wave. A signal being half wave, it can be even or odd. An even signal can exhibit half wave symmetry, or an odd signal can exhibit half wave symmetry. An even signal can exhibit half wave symmetry, an odd signal can exhibit half wave symmetry. What happens if the signal is even and half wave? What happens if the signal is odd and half wave? Odd and half wave, we must observe. Look here, if the signal is even and half wave, in the resulting Fourier series expansion, what will have? What terms will have? If the signal is even and half wave, in the resulting Fourier series expansion, what will have? See, even means what? Look here, even means Bn is 0. A0 is optional, forget about A0, it may exist or it may not exist, DC value. So the important quantity of even signals is what? An. Important quantity of even signals is An, which definitely exists. But as this is half wave symmetric, see, important quantity of even signals is An, but as the signal is half wave symmetric, so we'll have in the resulting Fourier series expansion we'll have An, but only for odd harmonics. An will have, but only for odd harmonics. That An only will exist, but only for odd harmonics. Now what happens if the signal is odd and half wave? Odd means what? A0 and An are 0. So the important quantity of odd signals is Bn, and this is half wave symmetry. So we have to take the combination. So in the resulting Fourier series expansion, if the signal is odd and half wave, we'll have Bn only, but that too for odd harmonics. Why odd harmonics? Because it is half wave symmetric. You have to take the combination. Bn for odd harmonics. Bn for odd harmonics. Signals which exhibit this kind of symmetry, even or odd at the same time half wave, even or odd at the same time half wave, is what is known as quarter wave symmetry. Quarter wave symmetry. Quarter wave symmetry means an even signal or odd signal exhibiting half wave symmetry. Quarter wave symmetry means even or odd signal exhibiting half wave symmetry. Even signal or odd signal exhibiting half wave symmetry. Exhibiting half wave symmetry. Right. So till now what we studied in Fourier series, if we recap, what is the purpose of Fourier series? What is the purpose of Fourier series? See, the purpose of Fourier series is that, look here, if you recap the salient points, what is the purpose of Fourier series? We can build a periodic signal. See, we can build a non-sinusoidal periodic signal by adding mutually orthogonal harmonically related sinusoids. Yes or no? So how we are going to add is given by the trigonometric Fourier series. This is the expansion, trigonometric Fourier series expansion. So here every term in the trigonometric Fourier series expansion, every term is mutually orthogonal with the other term, right? And A0, AN, BN are called trigonometric Fourier series coefficients. You can find out A0, AN, BN values using the expressions, and we have some discounts. Here harmonics means what? Multiples of fundamental are known as harmonics. And we have some discounts, that symmetry is there. Symmetry means what? Even signal, you need not calculate the value of BN, it is 0. For odd signals, A0 and AN are 0. And we have other symmetry, half wave symmetry. If the signal is half wave symmetric, in the resulting Fourier series expansion will have only odd harmonics. And the signal can be even and half wave. Even and half wave means in the resulting Fourier series expansion will have AN for odd harmonics. And let me write one more point here. AN for odd harmonics means cos terms. I can write one more term, cos terms for odd harmonics. Cos terms for odd harmonics. Cos terms. AN cos, AN means cos terms. BN for odd harmonic means sine terms for odd harmonics. Signals which exhibit this kind of symmetry, even or odd at the same time half wave, is what is known as the quarter wave symmetry. Alright. Now every signal cannot be expanded into Fourier series. There are constraints, as we are having constraints in Fourier transform also. But here now I am not going to discuss those constraints. Tomorrow I will discuss, but let's solve one problem. Trigonometric Fourier series expansion. Let's get one trigonometric Fourier series expansion. So I am taking a periodic signal. So let me take a periodic signal. First of all, we will try to analyze, and later on we will see whether our assumption, what we are analyzing, is correct or not. This is a periodic signal I am taking. This is J0. See, whenever I am drawing this kind of signal means here, the meaning is this is non-sinusoidal periodic signal. The meaning is this can be obtained by adding mutually orthogonal harmonically related sinusoids. What are those sinusoids? We have to observe. That itself is Fourier series, nothing is there. Now by adding what sinusoids you are going to get this periodic signal is the question, right? Now let's analyze. First of all, analysis. This is a periodic signal. Suppose if you are given this one. Now how to analyze this one? Period. Whenever you are given a periodic signal, first task is to find out the fundamental period. It's to find out the fundamental period. What is the period? Period is nothing but t. Omega naught value 2 pi by t. Right. Next, observe symmetry. Even signal, odd signal. Even signal or odd signal. This is even signal. Even signal. Look here. Even plus whether this is half wave symmetric or not. Let's observe what I said to understand half wave symmetry. Take some point. Look here. Take some point. I am taking some point here. So here I am between 0 to t by 4. I am taking the midpoint, which is t by 8. Now I want to understand whether this is half wave symmetric or not. To this t by 8, add half of the period. Half of the period is t by 2. What is t by 8 plus t by 2? 5t by 8. 5t by 8. So 5t by 8 means how much? It will be somewhere here. 5t by 8 will be somewhere here, whose value is minus a. Yes. So this is even plus, here the point at t by 8 and 5t by 8 are what? Are equivalent opposite. They are equivalent opposite. So the signal is half-wave symmetric. The signal is half-wave symmetric. Even and half-wave. So even and half-wave means, as per our discussion, in the resulting Fourier series expansion, what we must have? What we must have? An for odd harmonics, or cos terms for odd harmonics. An for odd harmonics. In the resulting Fourier series expansion, if you perform, An for odd harmonics we must have, right? So let's see whether we are going to get those or not. So even means what? Bn is 0. Bn is straight away 0. A0 may exist, may not exist. We'll see the nature of A0 also. But An, if it exists, it must exist only for odd harmonic. Now let's verify. So A0, calculation of A0. First of all, write the expression. 1 by t integral minus t by 2 to t by 2 x of t dt, or 1 by t between, look here, minus t by 2 to t by 2, minus t by 2 t by 2, x of t is even signal, no? How I can write? It is nothing but 2 times two by t integral 0 to t by 2 x of t dt. Now integration means what? Area, no? 0 to t by 2 integration means area. So A0 will be, calculate the area from 0 to t by 2. 0 to t by 2 means it is splitted, the first part is 0 to t by 4, t by 4 to t by 2. So 0 to t by 4, width is t by 4, height is a. So at by 4 is the area. And t by 4 to t by 2, width is t by 4, height is minus a. Area will be minus at by 4 by which is nothing but 0. 0. Remember, DC value or average value, if you want to calculate DC value or average value, A0 is nothing but area over time period. Choose one period, in that calculate the area. DC value or average value means over the period calculate the area. Over the period you calculate the area, you will get simply DC value or average value. Or if the signal is symmetrical along, now if you observe, this signal is symmetrical along horizontal axis, so its DC value will be 0. If the signal is symmetrical along horizontal axis, so its DC value or average value will be 0, which is evident here. The signal is symmetrical along horizontal axis, so its DC value or average value is 0. Or if you want to calculate over the period, calculate the area. Over the period, calculate the area. Observe here, integration means area only, right? Integration means area only. So area by time period gives DC value or average value. Okay, here A0 is 0, Bn is 0 from symmetry, A0 is 0 from the calculation. Let's find out An. An, how to find out? First of all, write the expression 2 by t integral t0, not t0, minus t by 2 to t by 2 x of t cos n omega naught t dt. X of t cos n omega naught t dt, right? Or An is equal to 2 by t. Here x of t is an even signal, cos is also an even signal. Product of two even signals is what? Even signal. and integral minus t by 2 means 2 times integral 0 to t by 2. So how can I modify this one? I can modify this as 4 by t integral 0 to t by 2 x of t cos n omega naught t dt, or an is equal to 4 by t, observe here, 0 to t by 2, 0 to t by 2, how I can split 0 to t by 4 plus t by 4 to t by 2. So 0 to t by 4, value is a cos n omega naught value you can substitute, plus t by 4 to t by 2 minus a cos n omega naught t dt. Now you can simplify this integral. I am not going to simplify, I am going to directly give the expression. I know your master set integration, I know that. So here an, if you simplify, you must get 4a by n pi sin n pi by 2 you must get. After the class you can verify. 4a by n pi sin n pi by 2 you must get. What is the nature of sin n pi by 2? The nature of sin n pi by 2 is plus or minus 1 for n odd and 0 for n even. Sin n pi by 2 is plus or minus 1, means a1 will be 4a by pi, a3 will be minus 4a by 3 pi, a5 will be 4a by 5 pi. Oh, I got the coefficient. Your job is done. Vamsi is a master, I know. Vamsi is a gem of impulse batch. Now a1, a3, a5 values I got. Sir, one thing I can say that Fourier series is very easy if you have patience. Fourier series says that add different harmonically related orthogonal sinusoids, you can get a non-sinusoidal periodic signal. But in what proportions you have to add, that is given by the trigonometric Fourier series expansion, nothing is there. Now look here, x of t is equal to, what is the trigonometric Fourier a naught? See, in our expansion a naught is 0, observe here, a naught is 0, a summation, trigonometric Fourier summation n varying from 1 to infinite, bn is also 0, an exists only for odd values. It is evident now, an is existing only for odd values, a1, a3, a5. So an cos n omega naught value is how much, sir? Omega naught value is 2 pi by t. Oh, that's it, that's it. Expand a1 cos omega naught t plus a3, only odd values you have to go, a3 cos 3 omega naught t now if substitute the values, a1 value is how much? 4a by pi cos omega naught t minus 4a by 3 pi so the given signal is even signal, so we don't need any sign terms, that is evident, right? What I suggest is, after this one you watch the video what I made on signal processing using Python. I did reverse engineering there. I took this signal there and I achieved this one. Generally we will get doubts, sir, by adding sinusoids whether we can get the periodic signal or not. Yes, you will get. Please refer that video once. Now it is proved not, look here, analysis what we made in our analysis, we have seen that the resulting Fourier series expansion, what we must have, an for odd harmonics. An means cost terms for odd harmonics. Observe here, we are getting cost terms for odd harmonics only. What is there? Understood? So in this way, we are going to get the Fourier series expansion. Nothing is there here. Very simple. See, a previous question was asked like this. They gave this kind of periodic signal. After this also we'll solve one sort of previous gate question which boosts your confidence. They gave this periodic signal and they were asking what is the amplitude of second harmonic. This is the signal x of t. What is the amplitude of second harmonic? What is the amplitude of second harmonic? What is the amplitude of the second harmonic they were asking. Now we started, now our play will start. Now look at amplitude of second harmonic means first of all analyze this is a periodic signal. What is the period? Shape at 0 is repeating at t means period is t. Period is t. Omega naught will be 2 pi by t. Next symmetry, even signal, odd signal. It is a odd signal. Whether it is half wave symmetric or not, yes, it is half wave symmetric also. Odd and half wave. Odd and half wave means in the resulting Fourier expansion, what we must have? We must have Bn for odd harmonics. Bn for odd harmonics. Already we have seen. Odd means Bn. Half wave symmetry means odd harmonics. Bn, odd plus half wave means Bn for odd harmonics. So odd harmonic means what is asking? Second harmonic. Or it won't be there. Answer is 0. Answer is 0. Very simple. Answer is 0. Yes, exactly. Now you tell me for this second next. Now this is your range question. Signum of cos t contains option A. Now you cos terms for all harmonics, sine terms for all harmonics, cos terms for odd harmonics, sine terms for even harmonics. Signum of cos t. A, B, C, D. First of all, let's draw signum of cos t. How to draw? So in order to draw signum of cos t, You must know what is the definition of signum t. Signum t, so is 1 if t greater than 0, is 0 if t is equal to 0, and is minus 1 for t less than 0. So that signum of cos t will be 1 if cos t greater than 0, is 0 if cos t is equal to 0, minus 1 if cos t less than 0. Cos t is less than 0, right? So in the next page, I will take cos t, zero, pi by 2, pi, 3 pi by 2, 2 pi, maximum value is 1. This is cos t. Already we have drawn signum of cos t in the initial discussions. After this problem, the next problem is very nice problem which we are going to play like anything. Next problem is very nice problem which you are going to enjoy. Observe here, my dear students. Here signum of cos t is 1 if cos t greater than 0. From minus pi by 2 to pi by 2, cos t is greater than 0. Signum of cos t will be 1. From pi by 2 to 3 pi by 2, cos t is less than 0. So signum of cos t will be minus 1. And this goes like this. This goes like this. It's like this. Yes. Now this is signum of cos t I got. What is the nature of signum of cos t? Even and half wave, no? Just now we have seen even and half wave means what? We'll have an for odd harmonics. An for odd harmonics. An means what? Cos terms for odd harmonics. That's it. Cos terms for odd harmonics means here options C will get. Take sinusoids of different sinusoids which are harmonic related and mutually orthogonal. If you are adding in different ways, you will get different signals. Non-sinusoidal periodic signals you are going to get. Then itself is Fourier series. What is there? Now look here. Let's analyze the next problem. Suppose I have this signal. The question is you have to get the trigonometric Fourier series expansion. You have to get the trigonometric Fourier series expansion for this signal. Trigonometric Fourier series expansion for this signal. But before going to get that, let's analyze with the knowledge what you have. Let's analyze and we'll see whether our analysis will be correct or not. Correct or not. How to analyze? Listen carefully. First of all, whenever you are given a periodic signal means fundamental period. Shape at 0 is repeating it 2. Fundamental period is 2. Omega naught value pi. Next comes symmetry. Sir, is there a symmetry? Even signal, odd signal? Come on. Even signal or odd signal? See, this is neither even nor odd. This is neither even nor odd. X of t is neither even nor odd. But look here, one important statement here is, this is not a odd signal, but I can make this as odd. Look here, I can make this as odd with the subtraction of a DC value. I can make this as odd with the subtraction of a DC value. What happens if I subtract a DC value half from this one? Observe here. What happens if I subtract? Assume that. What happens if I subtract a DC value half from this one? I'll get one more signal. Let's subtract. We are analyzing. After that, we'll see whether our analysis is correct or not. After subtracting a DC value half, I am going to get x dash of t here. Other signal x dash of t. From 0 to 1, what is the value of the top signal? 1. From 0 to 1, DC signal value is half. 1 minus half. From 1 to 2, top signal value is 0, bottom signal value is half. 0 minus half, minus half. And so on, it will go like 2 to 3, half, it will go on like this. Right? Now, x dash of t I got. Look here, let's analyze x dash of t. What is the nature of x dash of t? My dear students, if you observe, what is the nature of x dash of t? Here 0, this is 1. What is the nature of x dash of t? Period x dash of t nature, if I study, period is 2, omega naught is pi. So with the subtraction of a DC value, period, there won't be effect in the period. Okay, fine. Omega naught is pi. X dash of t is even signal, odd signal. It is odd and half wave also. Odd and half wave. Observe here. X dash of t is odd as well as half wave also. So in the resulting Fourier series expansion, odd and half wave means for x dash of t, a naught will be 0. X dash of t, a naught will be 0. X dash of t, an will be 0. X dash of t, bn will exist. But as this is odd, Fourier series coefficients exist only for odd harmonics. What is the nature of x dash of t? Period is 2, omega naught is pi, odd and half wave. A naught and an are 0, bn exists only for odd harmonics. Now, let's analyze x of t. What is the relationship between x dash of t and x of t? X of t is nothing but x dash of t plus half. If I add a DC signal half to x dash of t, I'll get x of t. Means there is only DC shift. Remember, there is only DC shift. Rest of the terms must be same. Means, look here, only DC shift. Means what could be a naught value for x of t? A naught value for x of t. DC is added. Now what DC value is added? 1 by 2 is added. Here I am subtracting a DC value from x of t to get x dash of t. Means if I add a DC value half to x dash of t, I'll get x of t. So DC value of x of t must be 1 by 2. 1 by 2. That is only the difference. So the rest of the term must be 0. If you calculate, an must be 0 for x of t and bn must exist, that too only for odd harmonic. Bn must exist for x of t also, and that too for, it must exist only for odd harmonics. Let's verify this whether, see, this is analysis we made, some analysis we made. Now we'll see whether our analysis is correct or not. Correct or not. Now look here. Let's find out a naught. For x of t I am calculating. Write the expression 1 by t minus t by 2 to t by 2 x of t dt. Or a naught is equal to 1 by t means what is the value? 2 minus t by 2 to t by 2 means minus 1 to 1, but this is defined between 0 to 1, 0 to 1, 1 dt. This is 1 by 2. So a naught value is 1 by 2. Please verify. Yes, verified, verified. A naught value is verified. An value, verify. An value. First of all, write the expression 2 by t integral minus t by 2 to t by 2 x of t cos n omega naught t dt. T value is 2 minus 1 to 1 x of t cos n omega naught value is pi t dt. See, 2 gets cancelled. Or an is equal to, what is that you are going to get? Minus 1 to 0, it is anyway 0 now the signal. So limits become 0 to 1. X of t value is 1 cos n pi t dt. Sin n pi t upon n pi 1 by n pi, sin n pi is 0, sin 0 is 0. An is 0. Verified, verified, verified. Now let's verify Bn. Write the expression first. Sin n omega naught t dt, or Bn is equal to 2 by 2 0 to 1 x of t value 1 sin n pi t dt, or this is minus cos n pi t by n pi between the limits of 0 to 1, or Bn value is minus 1 by n pi cos n pi value minus 1 whole power n minus cos 0 value 1. So Bn will be minus 1 by n pi observe here n can take even values, n can take odd values. What happens if n is even? 0 for n even. What happens if n is odd? Minus 1 whole power odd is minus 1, is 2 by n pi. Yes, Bn is existing only for odd harmonics. This is also satisfied. Now you can write the expansion. Very simple. First of all, we made analysis. Our analysis is correct. A naught is how much we got? 1 by 2 plus summation n varying from 1 to infinite. An is 0, Bn is existing only for odd values. 2 by n pi sin n pi t, or 1 by 2 plus give different values of n odd, 2 by pi sine pi t plus 2 by 3 pi this is the Fourier series expansion. Means look here, if you are going to add these kind of sinusoids, you are going to get this periodic signal. See, look here, this is DC value, no? This is DC value. This corresponds, see, this Fourier series expansion 2 by pi sin pi t plus 2 by 3 pi sin 3 pi t, this corresponds to your x dash of t expansion. Add DC value, you will get x of t expansion. DC value to get x of t expansion. This is x dash of t expansion, Fourier series expansion. This is half, this is x of t. Now my question is, after the class, look here, you do one thing. Whatever I say is not a constitution. You must think in your own way also. Look here. Here how I obtained symmetry? By subtracting a DC value. By subtracting a DC value, I obtained a symmetry, odd symmetry. Now here, what happens if you shift this x of t to the left by half? You will get even symmetry, no? Symmetry can even be achieved with the shift also. What happens if x of t is there? What happens if you calculate x of t plus 1 by 2? Shift this signal to the right, left by 1 by 2, then you will get even symmetry. So even symmetry also you try, you must get the same answer. Understood what I am saying? Here I obtained some symmetry by adding it, by subtracting a DC value. Now what I am asking you to do is, you shift this x of t to the left by half so that the signal becomes even. From even signal, so from even symmetry, can you get the same expansion or not? You have to verify. That experiment you have to do after the class. Again I am repeating, x of t is there. What I did, I subtracted DC value so that I made it as odd with the subtraction of a DC value. Now what I am asking you to do is, shift this signal x of t to the left by half so that this becomes even. From the even symmetry, can you get the same answer is my question. See, after subtracting a DC signal, it is becoming odd, means with shift also it becomes even. So in that way also we must get the answer. So your job is to verify that. You must get. Unless you do this kind of experiments, your subject will not improve. Let me tell you that. I can do it now, but there is no, I mean, there is no point if I get everything. Now, a previous gate question will observe. A periodic signal in a duration of 1 period, in a duration of 1 period is shown. Its Fourier series expansion includes, A, cos terms of hard harmonics, B, sine terms of odd harmonics. Very interesting question. Sine terms of, till now we haven't seen how to draw the spectrum of this Fourier series. Tomorrow I will discuss that. Cos terms of even harmonics. What is that signal in 1 period? Come on, try to answer this one. Try to answer this one. A periodic signal in a duration of 1 period. In 1 period, he has given a periodic signal. Its Fourier series expansion includes A, B, C, D. Come on. Vamsi Krishna said that his answer is D. Fazal Rasul has said that his answer is B. Pranay Gaud has said that his answer is A. But let's complete the signal here. We'll get the answer. Observe here. Let me draw the signal. So 3, 4, 5. This portion is given, right? Harish has said that answer is A. Okay, so 0, 1, 2, 3, minus 1, minus 2, minus 3 and so on. And this value is what? 3. This value is minus 1. Right. Now, look here. What happens if I backtrack? What happens if I complete the signal? So here, the signal can be completed like this, the periodic signal. 1 period he gave, no, means this will be, this shape will be repeating periodically. What is the period here? What is the period here? 1 period he said, so period is 2. Means between 1 to 3 also I will have the same shape, no? 1 to 3 also I will have the same shape. Periodic signal means it must repeat periodically. Between minus 1 to 1 also I must have the same shape, no? And so on. Now I got the signal. Now I constructed the periodic signal. Fazal Rasul, you have changed your answer. Let's verify. Now period is 2. Let's analyze this one. Period is 2. Omega naught is pi. Okay. Even signal or odd signal. Symmetry is not there. But what we call by the name hidden symmetry. Can you make the signal as odd with the subtraction or DC, with the subtraction or addition of a DC value? Ah yes, with the subtraction of a DC value I can make this as odd. What happens if I subtract a DC value 1? What happens if I subtract a DC value 1 from this one? Subtract a DC value 1. What will happen? So between 0 to 1, this value is minus 1. If I subtract, it will become minus 2 and it will go like this, like this, like this, like this. This kind of nature you will get. This kind of nature. This is 2, this is minus 2. This is if I call this as x dash of t. If I call puzzle, if I call this as x dash of t, again first analyze x dash of t. X dash of t period is how much? 2. With a DC shift there is no change in the period. Omega naught will be pi and is odd and half wave as well. Odd and half wave as well. So here odd means what? A0 and AN. A0 and AN will be 0. As it is half wave, BN exists only for odd harmonics. BN exists only for odd harmonics. I'll write here. Better you may get confused here. Let me write here. The nature of this x dash of t. A0 and AN are 0. BN exists only for odd harmonics. Odd harmonics. Right. Now, what is the relationship between x of t and x dash of t? See, x of t is equal to now observe here how we got x of from x dash of t. Can you get x of t? Yes. So only DC shift. What happens if I add a DC value? What happens if I add a DC value 1 to x dash of t? I'll get x of t. That will be only a change. So A0 will be 1 for x of t, AN will be 0, BN will exist only for odd harmonic. Only DC shift. Only DC shift. Right. So BN means cost terms. Sorry, BN means sign terms, no, not cost terms. BN means sign terms. Option B will become the answer. Option B is the answer. So this is about your Fourier series expansion, trigonometric Fourier series. Remember, Fourier series means how you are going to build a non-sinusoidal periodic signal using harmonically related mutually orthogonal sinusoids. In that process, we will try to calculate the values of A0, AN, BN. With symmetry, those values will change, and using the concepts of the transformations, we will transform one signal to other and we will get the results. So I'll do one thing, I'll stop our class here. Tomorrow, we'll see how to draw the spectrum, magnitude spectrum and phase spectrum for this trigonometric Fourier series, and after that we'll go to exponential form of Fourier series. Right. Hope you enjoyed today's session, but after the class, go through the video signal processing using Python. There you will get a clear idea how you are going to get the periodic signals by adding different sinusoids. What is happening? What is the effect of first harmonic? What is the effect of second harmonic? What is the effect of DC value? Everything I have done in that video practically. That is very good video. You please go and watch the video after the class, and I gave some homework also. This work also you have to do. This one. Which one? This signal. You try to shift this one to the left by 1/2 and see with even symmetry you are going to get the same answer or not. You must get. So tomorrow also you will be having a long duration class only. So shall we start from 7 AM tomorrow? I think that would be the right time, 7 AM. Shall we start from 7 AM tomorrow? 7 to 10. Shall we start from 7 AM? Replyer. And there are some conditions for this Fourier series expansion also, Dirichlet conditions, that also we'll discuss tomorrow. 7 to 10, yes, that would be right, appropriate. Tomorrow, once we enter exponential Fourier series, we will be playing only with the problems. Don't worry, today's topic also, tomorrow I'll summarize, and after the class you refer that mapping from S plane to Z plane also, where left half of S plane is mapped to inside the unit circle, right half of S plane is mapped to exterior of the unit circle and all. These are our channels. And you can follow me on Unacademy, unacademy.com @kvswamy. Most probably today we'll be having a session on PYQs. Yesterday we had a good session, PYQs on the whole signals and systems. Today also we'll be having from 5 to 7 on the Unacademy app, where we'll try to cover most of the questions. All of you try to attend that. And finally, thank you. Like the session, share the session, subscribe the channel and press the bell icon so that you will get regular notifications. Thanks for your patience. Tomorrow also come prepared that we are having a long duration class. Thank you.